This is statics, chapter 6, truss, and we will use the section method to answer some questions. So the question is, what are the load, the force in the member kg, kd, and cd? So this one, and this one. So the most natural thing is to make the cut, beautiful cut, rainbow cut there. Okay, can you say something? No, let me make it in red. Okay, so we will cut there. Because the question is to find kj, kd, and cd. If we want to use the joint method, we need to go joint by joint, and that's a bit longer. Okay, there is something that we need to do first, because when we will cut there, we will keep either the right or the left side of the truss, but we don't have the force at the reaction. So I will probably keep the right side, because I will just have one vertical unknown, or I can keep the left side. Let's solve for the first. So one, we did the cut. Okay. Second, we need to find the reaction at A and G. So let's do that. So we will use the entire truss as a free body diagram. Okay. The four that we know are the 20, 30, and 40. And the four that we don't know are the AY, AX, and NG. I write N because it's a normal force, because it's a smooth contact, it's a roller contact. And we need some dimension. So we need the 2 meters, 2 meters, 2 meters, and to the right is 6 meters. Okay, so now let's do our equation. Okay, so let's solve for x. Sum of the forces on x is equal to 0. And the only force that we have is AX. So AX is equal to 0. Let's do the moment about A. Sum of the moment about A is equal to 0. So we will find NG. So we have this force that is going in the negative directions, negative directions, negative directions. So minus 20 times 2 for this one, minus 30 times all the distance from A, so it's 4, minus 40 times the distance from A, so those 6 meters together, and NG is rotating in the positive direction, so plus NG times 2 plus 2 plus 2 plus 6, so 12 meter. It's equal to 0. So we found that NG is equal to 40 plus 120 plus 240 divided by 12, and G is equal to 40 plus 120 plus 240 divided by 12. That's 33.3. 33.3 kilonewton. Okay. So I just look at, okay, on your book it's solved with the left side. We can find AY, but let's find AY. So sum of the forces on Y is equal to 0. Or we can use the moment about G, okay, either. We have AY minus 20, minus 30, minus 40 plus NG is equal to 0. So AY is equal to 2 plus 3 plus 4. So it's 4, 5, 6, 7, 8, 9. So it's equal to 90 minus 33.3. So AY is equal to 57.6. 66.7. 66.7 kilonewton. Okay, so now those two forces, we can turn them, let me just write a little blue. Okay, so let's come back on this one, and we can add in blue NG, that is 33.3, and a y that is 56.7. Okay, so now do we keep the left side or the right side to solve for our unknown? Pick a side. Number 3, pick a side. I see. So in your lecture, it's solved with the left side, so let's do the right side there. Okay, so we will use right side of the choice. So the free body diagrams, it will include this there. Yeah. So let's draw the free body diagram of the right side, and let's see it's exactly like if we just keep this. So free body diagram, this, this, and this, and this one there. Okay, so let me add the 33, 1, 3, and at point D, we also have the 40. It's kilonewton, both are kilonewton. Okay. The 4 that we don't know, and let's put them in tension. Oops. Yeah, like this exactly. So let's put this one O, and this one. Okay, so this one on the top is FKG. This one is FKD, and this one is FCD. FCD, I need to show you the point a little bit more. And so let's write the point. This is K. This is the point D. And that's what we need. Okay, missing some geometry in our equation. So what we will do, if we think about our equation, to solve for FKG, we will do the moment about D. It's equal to 0. So because FKD and FCD are going through D, so we need the dimensions from D. And we will do the moment about K, because KG and KD are going through K, so we will be able to solve for CD. And for this one, we will do the sum of the forces on Y, it's equal to 0. So we need some information. We need, oh, this is 3. Okay, so we need that this one is 3. This distance between this one and this one is 2 meters. Okay. So this is 3, this is 2, and at the square root of 9 plus 4, so the square root of 13. Or you can find the angle. Okay. Here we go. Okay, oh, and we miss the dimension from D to G, this one. For this one, this is 2 plus 2 plus 2, this is 6 meters. Okay, so you see we keep the right side of the truss. We include the point that we will need for the moment. We don't forget to include, a common mistake is to forget this force. Don't forget this force, okay? We don't include those that are not inside our body, but we need to keep all the external load that apply to this body. Okay, so make sure that you include all of them. So that's our free body diagram. So now let's solve our equation. Which one do you want to do first? Let's do the moment about D. So sum of the moment about D is equal to 0. This one. So this one, and this one are going through D. So we have this one that is in the plus direction. So we have 33.13 times 6. And this one is plus FKG times this distance there times 3. It's equal to 0. So FKG is equal to minus 33.3 times 6 divided by 3. So FKG is equal to minus 66.6, maybe 7. if I don't round. Oops, here we go. And the minus means that we didn't get the right direction, so we guess tension, so it means that is in compression. Okay. Let's do the moment about K. Sum of the moment about K is equal to 0, so that's our point K. Okay, so which forces do we have? We have this one that is rotating in the negative direction, so minus 40 times the minimal distance between the point K and the 40, that's the perpendicular distance, that's the 2, so times 2. This one is going in the plus direction, the 33.3, so plus 33.3, and the distance between this point and K is 6 plus 2 is 8, so times 8. That's for the two moments created by 40 and 33.3. And FCD, so FCD is going in the negative direction. So we have minus FCD times this distance there, that is 3. It's equal to 0. Oops. It's equal to 0. So we have FCD times 3, that is equal to minus 80 plus 33.3 times 8. That's 266. 2666.4. Let me use the exact number. Try to keep your exact number to 6.6. You see, it changed like 7. Divided by 3. So FCD is equal to this one minus 80 divided by 3. That's 62.2. And it's plus, so we get the right directions. So it means that we guess tensions, and yes, it is in tension. Okay, so we have 1, 2. Let's use the last equation that we want to use. So sum of the forces, and you can use ax too if you want. I just like y because y does not include fkg and fcd that we just found. So if we did a mistake for them, we don't reproduce the mistake there. So fkd, fy, it's equal to 0. So we have plus fkd, but just the vertical component of kd, so this one. So that's times 3 divided by square root of 13 minus 40 plus 33.3, it's equal to 0. So fkd, it's equal to 40 minus 33.3 times square root of 13 and divided by 3. So we have fkd, it's equal to 40 minus 33.3 times the square root of 13 and divided by 3, 8.05 kilonewton, and it's plus, so it's tension. We guess the right direction. Here we go. So, oops. So let's come back on our steps, what we did. Oops. I should write four, oops, 4 free body diagrams, and 5 equation of equilibrium. Okay, so let's go back on our steps. First steps, we look at the truss, we determine where we will cut, and when we cut either the left side or the right side, they both have unknown that are the reaction forces. So we need to do the free body diagrams to find the reaction forces at A and G first. So that's what we did inside this little part of the page. After we found AY and NG and AX at 0, after that we decide which side we keep for the for the analysis of the force inside each member. So we keep the right side, we kept the right side, at this one, so we kept the right side, we did the free body diagrams. Don't forget to include all your external load and direction force. Draw your forces, I like to write them all in tension, and after that, decide which equation you will do. So we'll do the moment about D to find FKG, the moment about K to find FCD, and the force on Y to find FKD. And there's a lot of options. You can use any three equations you want, just sometimes you have three equations, three unknowns, and you need to solve for a system of matrix. And we prefer to avoid that. Make sure that you have all the dimensions that you need to do your equation of moment or your equation on x and y, so some angles. And we solve for the three equations, and we could solve for them in any order, okay, because they are independent. And I just check my answers. Yes, that's correct. And the compression there. Yes, that's correct. So that was the first example for the section method. Take your time, but there's always ways to make some shortcut to avoid to have to do too many free body diagrams and equation of equilibrium. See you for the next problem. Bye bye.